Hello everyone, I'm Bridget Seegers, a research scientist in the NASA Ocean Ecology Lab, and I'm going to take you on a journey in my presentation from cyanoslime to solutions with satellites. You will be learning about the CyAN project, otherwise known as the Cyanobacteria Assessment Network. The CyAN project is an interagency effort combining the talents at NASA, US EPA, NOAA, and the USGS. The project focuses on cyanobacteria, which are photosynthetic bacteria. That means they use sunlight to grow. In the top right, you can see a microscope view of tiny and bright green cyanobacteria. Now, cyanobacteria are a normal part of both saltwater and freshwater aquatic systems, but at times they can grow to huge numbers, and although they are microscopic, they can have big and very visible impacts. These events that result from lots and lots of cyanobacteria or other algae are called blooms. In the middle right, you can see a glass of water from a lake during a cyanobacteria bloom, and you can get a sense of how dense these blooms can be. On the left is a Landsat satellite image of the western part of Lake Erie, so you can also see how large these cyanobacteria blooms can be. In this image, we're talking hundreds of kilometers. Now, the reason we focus on these cyanobacteria blooms is not that they turn the water green, but they can actually make the water harmful. Some cyanobacteria produce toxins, and these toxins in the water can make for dangerous water conditions. The image in the lower right is a drinking water intake in Lake Erie for the city of Toledo. About 400,000 people rely on this drinking water supply, and when this bloom happened, the water turned green and it was deemed unsafe to drink or cook with for over 2 days, which led to water supply troubles in the area. Now, these images focus on Lake Erie, but the cyanobacteria issues reach far beyond Lake Erie's shores. These images are from water bodies around the United States and from around the world. You can see bright green cyanobacteria in huge numbers. I mentioned that the blooms can produce toxins, which means these blooms have impacts on wildlife and human health. The blooms negatively impact drinking water supplies and limit recreational opportunities. Nobody wants to swim or kayak or canoe or even fish in these lakes. And dogs have gotten sick from swimming in the lakes as well. And someone should really let that dog in the lower left know that it's not safe to be out there swimming. As you can imagine, many aspects of these blooms not only hurt public health, but have negative economic consequences. From tourism to property values, these cyanobacteria have quite an impact. You can see the sign in the middle picture that says, "Don't touch the water because it's unsafe for contact." This is a situation that water managers and the public would like to avoid. Therefore, there is a great need to study these harmful cyanobacteria blooms, and that's what we are doing as part of the CyAN project. There are a variety of ways to study cyanobacteria. You can see the nets and jars on the left. That's a plankton net, and that can be used to grab a sample from a lake, and then you can take it back to the lab and look at it with a microscope to find out what's growing in the water. You can see the sampling going on along the bottom in some thick green cyanobacteria blooms. Might not seem like the best job, but someone has got to do it. These more traditional ways of sampling, using nets and jars and sending people out, tell us a whole lot about what's going on in the water. But as you might guess, they are time-consuming and labor-intensive, and it's hard to have enough people sampling to keep eyes on all the lakes all the time. Our goal with the CyAN project is to help develop tools necessary to use satellites to monitor for these cyanobacteria bloom events. You can see the graphic in the top right, and it's showing the satellite traveling around the world. It's gathering data as it goes around and around and around. The nice thing about satellites that we use for the CyAN project is you get global coverage every few days. That's a lot of lakes that the satellites are keeping an eye on for us and letting us know about the state of the water quality. Here are some actual examples of the satellite products that the CyAN project provides for people. On the far left, you can see there are true color images. On the top is an image from Minnesota, and the lower image is from Wisconsin. In the middle, you can see our satellite products that we produce that show estimates of cyanobacteria using the Cyanobacteria Index. And it's actually the same image that we are also seeing in the true color. So those side-by-side images are from the same day and from the same data. The Cyanobacteria Index image shows land in brown, and then you can see all the rainbow colors sprinkled around the image. And those are actual lakes that have cyanobacteria in them. It's super cool. That satellite product really makes the data jump out, especially when you compare it to the true color images. If you look to the left, at least for my eye, it's quite a challenge to pick out the areas, the lakes that might have a lot of cyanobacteria. And then if you look in the middle, those bright colors really jump out and let you know you might have a cyanobacteria problem. You will also notice in those middle images that there are some black and dark gray areas. So that either means there's very low cyanobacteria counts, so there's no problem, or it could be an indication of a lack of data. On the far right, in the middle, you can see there's a side-by-side image actually of Lake Okeechobee in Florida. And again, it's the true color and then the cyanobacteria index on the right. So imagine being a water manager and being able to zoom in on an individual lake, and you can see exactly where the problems are. And if you need to, then you can go out and put up those beach closure signs, and hopefully you can do it before the public gets there and gets exposed. So these satellite images can be very helpful to water managers. Another exciting thing about the satellite data is that it's part of a long time series. On the top left, you can see satellite images of Lake Erie from 2002 to 2011, scrolling by. And now, with the Cyanobacteria Index, we can actually turn those old satellite images into estimates of cyanobacteria in the lake, and we can look for changes over time. This can lead to some very interesting science. The image on the right is actually a summary of 4 years of data from Central Florida, from 2008 to 2011. The colors in the lake, from blue to yellow, represent the frequency of observed cyanobacteria events that occurred in a high-risk category. An area of blue has a value of 0, indicating the area had no high-risk cyanobacteria blooms over the 4 years, while the yellow indicates that all observations from the satellite over 4 years were categorized as having a high-risk cyanobacteria bloom. It gives us and the water managers some insights into which areas have major cyanobacteria problems. That image on the right demonstrates a summary for individual lakes in a region. The map on the bottom is another way to summarize cyanobacteria satellite data for the entire United States. Each hexagon in this map represents a state, and the colors represent the frequency of a certain type of bloom event. Blue means there was no bloom indicated in the satellite data, while the greens mean there were a bloom. The light green means a low bloom, and the dark green means a high-risk bloom event. So this is just another example of the type of analysis that can be done with data like the CyAN satellite products. A big goal for the CyAN project is to provide reliable satellite imagery to help monitor for cyanobacteria blooms. And then hopefully this imagery will provide decision makers and resource managers with the data they need to make good decisions. But we also want to get the data into everyone's hands. We want citizens to be able to use the data to figure out, maybe where do you want to go with your canoe or get out fishing, or maybe you just need to find a lake to jump into to cool off. Well, the great news is that our collaborators at the EPA have made a CyAN app, which literally gets the data into everyone's hands. So these images here are screenshots, and you can see it's a Google Map interface. And if we look along the top, you can just zoom into any lake you'd like. You click on that lake, and if you look at that middle image, you can see some numbers pop up. So the numbers are cells of cyanobacteria per mil, but the good important thing is that they're color coordinated. So green means good, yellow, orange, and then red would mean it's not a safe body of water. So you can learn about the water conditions based on the most recent satellite imagery. You can see to the right, there's a zoomed out image, and you can see a series of lakes, and then in those lakes a number of pins have been dropped. You can see the different lakes have different colors. One's green, there's some yellow pins, and then also an orange pin. So again, you can compare lakes in the area. And the final image to the top right actually shows you can use the app to look at lakes over time. So on the x-axis along the bottom is time, date and month, and then on the y is how much cyanobacteria is in the water. So you can look at how a single lake changes over time and also how the lakes compare through time. The last image on the lower right is Lake Okeechobee, and this is another app feature. If you would like, you can actually look at your lake and look at the actual satellite data, and you can see what's going on in that individual lake. Well, we've come to the end of my presentation. Hopefully you learned something new about the CyAN project and about satellite remote sensing of inland waters for cyanobacteria. Thank you so much for listening, and take care.